This is Electric Universe Eyes, and today I had a crazy idea. I'm going to try to recreate a hypothesis by a couple of people. The most notable in my mind and influential is Peter Mungo Jupp on electrified fossils. But this isn't why I'm making this video today. There's a gentleman named Roger Spurr on a channel called Mudfossil University. He's got quite a fascinating idea about the history of our planet. A lot of things that coincide with mythology and things that I'm into. However, the basis of his is that all of these surface features we see are the remains of titans or giant biological beings or dragons that physically made up mountain chains and all of that. So, man, I'd love your work, Roger, but I think the electricity side of it is more plausible in my mind with the mythology and all of those stories related to the planets. So forgive me. Hey, I could be wrong, but anyhow, you've inspired me to do this experiment today with this fish. So here is this fresh fish. He's passed away. Rest in peace, fishy. We are going to try to fossilize him. So I've got this clay right here, which is actually the very finest, choppiest, bubbliest, chocolate milky remains of foamy mud after fixing one of my sprinkler heads. And I dug down about 2 foot into the clay, washing all of that out. This is what settled the next day, so I put it all in here. I've got a thick layer of just pure dark brown clay. So lots of iron and minerals in it. And my idea here is to take this and this little fishy guy here and this jar with these 2 electrodes wired with DC. This is the cathode and this is the anode. And I'm gonna make this a little bit more wet and get some really fine mud and pour it in there with this little fishy guy in there as our scientific donation to life. And thank you, universe, for us helping figure this stuff out. Sorry, fish. I got some eggs. I wanted some calcium to make sure I got some calcium in there that if this thing can turn into a fossil with electricity, you know, if this is ground up, included in this fine mud, will that lend a hand? As well as I was shaping a piece of celestite crystal that I had retrieved the other day and had this really fine celestite crystal water mixture here. So I'm going to include that in there as well. I believe it's strontium, if I'm not mistaken. Anyhow, let's do it. I guess first of all, I'll just take what I got on this and put this in there. It's not very much. Kind of in the bottom. And let's take this eggshell. Look at this, what is this? I'm not sure what it is. It's a fine grit sandpaper. I'm not too sure how well this is working. Does this seem crazy already that I'm going to try to make a fossilized fish? Can I turn this fish to stone with electricity? And I'm going to be using my 10,000 volt transformer through my bridge rectifier so that it's DC. It's only 0.03 amps, so it's very low amperage, but it's high voltage. It's going to take a lot longer to dry this thing out once it's in there. Let's see what I got here. I'm going to add some distilled water with minerals added for taste. What kind of minerals do you say? Potassium bicarbonate and potassium chloride magnesium sulfate. Great. These are also magnesium-coated screws as well that I'm using as an electrode. And that one's got some extra copper wound all the way down, and that one doesn't. I don't know why, just because I was bored one day. There you go. Let's pour us some water. Right there. Really, I just want to get some of this mud right here separated. It's like a fine sand on top. It's got reds and grays all mixed together. That didn't look too pretty. You know, it doesn't smell good either. This smells pretty bad. All right, I got me a nice mixture there, so I'm gonna go ahead and put all these crushed eggshells in there. You know what, for fun, I'm gonna add a dash of baking soda. That was more like a couple of pinches, not a dash. While we're at it doing a custom recipe, let's just throw whatever I find on this table. So this looks like some random salt, water softener salt, Epsom salt, synthetic black iron oxide. That's nice. Let's do that. Let's throw that in there. It's the witch's brew. I needed to clean up my table anyway since I finished that last experiment. I kind of reorganized. You probably can't tell, but you know, maybe so. All right, a little bit of salt's in there. And we'll just mix her on up. All right, so now that we got that done, let's take this little dude. Dun it, 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 dun it. It's totally not the right music, but there's our little dude. So this is how he's going to be positioned. Have one on that side and then one up here. And the idea is to have maybe one higher. So this will be the positive anode, which is where the oxygen should be attracted to. And then hydrogen gas should be attracted to the cathode on this side. So I expect to see bubbles on both sides. This should be sucking up like a tornado. This should be pushing down like a hurricane if we could see it underneath the water. It's a really amazing video Billy Overton did in 2015 that showed that. So maybe I can highlight that one day, but that's what we're gonna do. All right. So then let's take our chocolate milk stuff. See, and I don't want all of that on top. I need to get another container. Whew. So I kind of had an accident mixing this up, and I got black iron oxide everywhere. It's excellent, awesome. But I dried it up as much as I could and wiped everything down. But what I was doing was mashing and scraping all of that stuff through this screen here, including all the eggshell. So everything that was in there that was hard that you just saw now just turned into part of this mud. All right, so you can see it's more like chocolate milk. There's some layer of mud in there, a little bit of chunky stuff. You can see how splattery it is. It's literally the consistency of thick chocolate milk. So I'm gonna roll with everything that I got here and see if I can fill it up. See if I could do this without dropping my phone in it. Oh, I got an idea. All right, here goes a little fishy guy. There are still some chunky pieces in here, so not too much. just a few little pebbles and things, not very large. Looks like the fish flipped over too. Pour that rest of that stuff in there, get it to fill all the way up. And he's looking like he's kind of buoyant. I don't know how well this is gonna work out. Fish out of water. That'd be totally psycho if I turned the electricity on and he came back to life. I had him in about 20 gallons earlier, but I don't know. It's probably just too quick. I set up the temporary aquarium too quick. Casualty. All right, so here's our dude. Can't really see him. Man, he's floating. All right, I had to kind of push his tail down so it kind of wedged in naturally on the edge of this jar because I was wanting to float around. So I let it settle for a couple of hours, and this is where it's at so far. I think I'm going to let it settle again until that gets extremely clear. Maybe I'll pour some more on top because you can see the little dude hanging out. But hey, maybe that'll be cool too. I don't know, we'll see. Okay, so I made a huge mistake. I was gonna come back and do this last night. So guess what? It's the next night. And I walked out and little fishy dude had floated to the top and was exposed. And this place was smelling horrible. You can see how much it settled and I couldn't take it. I just had to take him out, get him out of here. So my whole goal is to preserve something that was freshly alive, not something that already started rotting. I'm gonna keep that part and I'm going to dump out all of the water, and I will start with some fresh water, some additional mud, and I have one more fish that I actually froze. It's a rainbow trout. It's frozen, obviously. It's in a little bit of water. It's great to be able to just place it in the mud. And then I mixed up some fresh mud and we'll put that on top and get this started. All right, this little guy smells a lot better. I broke off the tip of the ice and then also right off its tail. So I'm just gonna drop it in like that. Bloop. All right, so I've got one electrode that is all the way down there in the bottom, below it. So that one's pretty much going that way. And then I've got this other one that's going to be at the top section of the mud. All right, let's mix up some mud. Good old Texas chocolate milk. That's what we eat before we go out and gather our cows. I don't know. Pour this in there. Oh yeah. Try to cover up that tail. Oh, I got a big old chunk in there, so at least we know there's two big, fairly big chunks that will either be on top or the bottom. So when this is all said and done, I'm gonna break this jar apart and we'll see, did the fish actually absorb the minerals and turn to stone through the process of electrolysis? That's what I'm trying to recreate here. Just push that tail down in there a little bit. All right, I think everything is good to go. So, see if we could see anything over here. I can't really, just some mud. May clean that up because that's conductive, or can be conductive. I'm gonna clean that up first. Okay, I finally got it all cleaned up and ready to go. Let's just take a look at it before we start. Do you see anything special down there? No, man. I just see a bunch of gosh darn dago clay right there, man. It looked like some water's already separating right there on top. I got my two electrodes right there. That one right there on the top side, that one's gonna be my negative cathode. And this one right here on the right side, that one's gonna be my positive anode. So, again, through the process of electrolysis, the H2O is going to split into hydrogen and oxygen. Oxygen will be pulled towards the anode, so we should see a lot of oxygen bubbles coming off of this bottom side. And hydrogen gas will be pulled over here, which again, we'll still see bubbles just not as many.
Let's see what happens.
All right, I got number 4 on. Time to hit the juice. And now it's a waiting game. There we go. Now we can see exactly what happens. Ooh, I start to see some bubbles there. Let's try. Yep. I think I like this the best. Is that a bubble starting to come up? That might be that gob of mud that fell in last. I saw a decent sized chunk and then a little smaller one. But I do also notice an air bubble forming around the anode. Even the cathode has, what is that around the cathode? It's kind of swirling. It's trying to make sure it's not a reflection. What is that? Oh, it's actually bubbled up around it. It is warm today, so I'm working towards getting an air conditioner. I thought summer was almost over with this last storm because it was really cool for a day or two. It was nice. And then, anyway, what I wanted to say is thank you to those who have given me donations. There's a lot of stuff I want to get. Make my experiments better, my environment better. And there's an air conditioner that is a heater also. Anyway, if you want to help me out, any donation, $1 or $1 million is fine. But paypal.me/electricuniversize, I promise I will put it to good use. You can leave a comment. If you want me to shout out your name or leave you some credit somewhere, I'd be happy to do so. Much obliged. Again, I appreciate everything, guys. Hey, it's bubbling now. Excellent. It's 9:33 Central Standard Time right now. So just wanted to note the time to see how long I end up doing this for. Because obviously I want this to run a charge through it until it's completely devoid and depleted of H2O water. And there's quite a layer on top, and that might take a while, but again, that might show us what this process is like. It is starting to foam up. It's like foaming around the mouth. Yeah, there's some bubbles.
It's fun, isn't it?
Well, since this is not an extremely high-powered, high-amperage test, I made this comment about Mudfossil University and Roger Spurr. I did some more digging and looked at some of his earlier papers, and I've got one that I wanted to read to you guys while we're sitting here watching mud dry. So this is written by Roger Spurr. Forgive me, I don't have the date that he wrote this or published it. I'll put a link on where this is published if I can find it again. But it is titled Mudfossilization of Soft Tissue. Abstract. This work is about a previously unnoticed soft tissue fossilization process. Dinosaur footprints are common in the Triassic rock of central Connecticut. However, a fossil bone or any other animal fossil has never been found in the wet soils of Connecticut, according to experts at Yale. 1. Fossils of soft tissue and bone are thought not to preserve well in wet soils. 2. Wet oxygenated porous soils will not preserve organic matter in, quote, traditional fossil form, but instant anaerobic death in wet electric clay and microscopic platypolar silicates can create exquisite copies of the entire original creature in some cases. 3. Quick, cold, deep, fine mud in what was likely a mudslide appears to have encapsulated these specimens instantly and without oxygen. They simply cannot decompose and wash away when death comes in this manner. Thesis. Traditional fossils discussed ... Most preserved bones are found in porous sands or soils which are primarily porous and dry. The soft tissues, skin, muscle, tendon, cartilage, organs, etc. are usually scavenged and or decomposed and quickly stripped of anything consumable by bugs and microorganisms in porous oxygenated soils and sandy conditions. The decomposed organic matter becomes particles in the soil. In dry soil, the central calcium bones are mineral and remain mostly intact. The result is the most basic bone structure with no organic fleshy detail. Mud fossils discussed ... Mud fossils are virtual copies of the original creature, exactly like petrified trees. Blood and flesh are sometimes unable to escape in these type of mudslides due to compaction. In mud fossils, the bones do not have the mineralized, spongy center look. The reason is ionic and nucleophilic invasion and conversion of calcium and phosphorus into other minerals. Primary invaders are ionic and OH-, hydroxide.
Is often the major invader in deep muscle fossil tissue.
Natural electricity in wet soils discussed ... The continuous wet soils generate, quote, spontaneous electrical potentials, end quote. See, Roger, you're talking about electricity. We butted heads on the whole gigantic dragons being mountain ranges and stuff. That's the only thing I disagree with. But anyhow, I love this so far. Sorry, I won't interrupt again. Where were we? Yes. Spontaneous electrical potentials. 1. These currents affect any materials with polarity. I call the process mudfossil electrolysis, identical to plating cheap jewelry. These electric currents in the mud drive platypolar tiny crystals to invade the surface of highly reactive ionic soft tissue. The molecular-sized tiny plates are flat and polarized. The electric current literally plates the soft tissue surface by electrolysis, which changes the original material due to molecular bonding and nucleophilic substitution with invading chemicals. The result is like shingling a house and protecting the contents within. Skin is 50 times more concentrated in silicon as other body parts. Silicon dioxide is exactly what covers many of the specimens, and that layer was tested 100% human mtDNA. Final report due in September 2015. Well, it's now 2020. Flesh turns to feldspar from electrolysis ... Mineralization and crystallization creep into voids created as VOCs sublimate out, leaving metal seeds and carbon. Another similar process is plating cheap jewelry. I have done earth electrolysis experiments with chicken tissue in 12-volt DC and various soil substrates. 2. The results show amorphous quartz and various feldspar buildup. Feldspar consists of a conglomeration of amorphous layers of silicates attached to each other by crystal bonds. Once the surface of organic fleshy tissue is coated with the crystals, the process begins to restrict the molecular size allowed in. The plating becomes very restrictive of new invaders, actual molecular size. Finally, H2O and OH negative are so tiny they are allowed but almost nothing else larger. OH minus or negative is highly reactive to bone chemicals and renders them unrecognizable eventually after chemical reaction. Ooh, let's take a look. It's bubbling up some more there. Interesting that this reading goes along with what we're doing, right? Wink, wink. All right. Fascia, a new science is discussed. ... There's only 2 pages and I'm almost done. Here we go. The body parts are separated by a fascia layer as they are when alive. After cold compacted death, this fascia preserves organ systems, blood vessels, and bodily fluids. This is because fascia and keratin are not water or enzyme soluble. And this is all in caps.
Uninterrupted moisture is the key to preservation.
Well, hey, check this out.
We got some moisture down here, baby.
It smells like fish, though. Let's see what happens. All right. Sharpie's fibers are present with the reticular tissue penetrating fascia to bone. 3. Under the fascia is the periosteum layer. In the periosteum is a layer of soft tissue including the tendon sockets, and ligament sockets, and blood vessels, and canaliculus and lacunae, which are, quote, soft tissues, and are normally gone in dry mineral fossils. The fascia fabric protects soft tissue in distinct packages, organs, tendons, etc., and may be broken up along these facial planes during glacial tilling resulting in, quote, body parts. Yikes. Methods, ... This research was done by Roger Spurr, an independent researcher in Middletown, Connecticut, over the course of several years. rspurr@gmail.com. Conclusion, ... Soft tissue preservation is possible in wet molecular size silicates. Basically very fine clay and mud. The finer and deeper and colder and quicker the encapsulation, the better the preservation. The continuously wet soils generate, quote, spontaneous electric potentials, end quote. The polarity of tiny crystals under electric influences react vigorously with ionic organic matter. Electrolysis is the catalyst using platy polar silicates and percolates in the wet soil as the electrolyte. The crystals coat and seal the surface of the organic tissues. Silicon, quote, I believe, and also iron in blood, Fe2 and Fe3, is the known soft tissue preservation agent. And 2, in this case, the blood with iron is not washed away and may be the source of this exceptional preservation, as lungs appear to preserve exceptionally well. And then he provides references. So again, if I find the link, I'll share that with you. And now look at all these other bubbles. So glad it doesn't smell like fish anymore.
Alright, guys. Just had a crazy idea. I'm always doing stupid ideas. So, here's my idea. And how do I do this without causing a problem? I'm considering adding an alternating current. What do you think about that? No, I'm not going to do that. I'm not going to do that. Because I want to see what happens here. And one weird thing I'm noticing right now is look at that bubble. Look at that bubble. It's moving. That bubble is moving towards the cathode. Am I crazy? Well, definitely, but... It is moving, look at that. That's cool. Yeah, I was gonna stop the video and time lapse, but I don't think so. This is starting to look cool.
Ooh, it's been just about another hour. It's insane. Looks quite different. So that little mound on the left, looks like there's a crack forming on the north side that bubbles are coming out of. So perhaps that's where hydrogen is expressing. And then on this other side, it's very obvious that oxygen is arriving there. See all these bubbling. All right, it's been another 45 minutes. Well, how ironic is this? One of my fish that I have in an aquarium inside just died, and it's one of my algae eaters. Just found him floating at the bottom. Poor little dude. So, well, I'm gonna donate him to science because he is absolutely fresh, and I'm gonna put him on top. I'm just gonna drop him in. So, didn't quite go in like I wanted to all the way. However, I'm just gonna leave it like that and see what happens. So. Man, it sucks. I'm disappointed. My fishy died. Damn, that's a bummer. Well, buddy, maybe we can preserve you forever. Yeah, I just pushed him just barely under the water, so we'll see what happens there, and maybe you can see what happens in the time lapse. So I'm gonna switch back over to the time lapse. But before I do that, zoom in and take a look at this here. The anode looks interesting, like I expected. It's all bulging up and fracturing around where it's pulling that oxygen and bringing all that mud up with it. And then the other side would be going down. So the anode would be like a tornado where it's sucking the oxygen up. And the cathode would be more like a hurricane where the energy or the force is pushing in. It's blowing, it's pushing down. So Again, this process makes sense visually here, so anyway. I guess there's a good chance I will see you tomorrow because it's already 1 in the morning, and just gonna turn the power off and reset it, and then I'm gonna switch back over to time-lapse mode. Woo! All right. Well, it is 3:39 a.m. on Tuesday, September 15th, and it's changed some. It's looking weird, but definitely increased in intensity from earlier. Well, I'm gonna just leave this thing running all night long, and I'll be back. Whew. Good morning. It is 6 a.m. on Tires Day, Tuesday. Look at this. Dude, my fish kind of disappeared. Where'd my little fishy go? Barely make him out. Seems like it sunk. There is still lots of water in there. So, let's just go by what Mr. Spurr said in his paper. As long as there is plenty of water, the body will not break down. He had an argument with me the other day on a Brian Forrester video, and it was in regards to these giant concretions. And he was saying that they are tendon balls, which is cool, man. I mean, I get it. I get it. You think they're giants and stuff. Perhaps, but guess what? I do stuff with clay, and man is supposed to be of the clay. I don't know. Maybe there's giants. I don't know, dude. Look, we're just gonna see what happens right here. I'm exhausted, so we're going back to time lapse. All right, so it is Tuesday at 3:30 in the afternoon. It's been almost a full day of 10,000 volts, 0.03 amps, it's 30 milliamps. Looking, smelling a little funny. Ugh. That's so weird, that color on top. It's like it's separated out. The oils is what it looks like, but it could be the little electrodes. Definitely looking a lot more extreme than yesterday. So again, at the anode, everything is risen up and everything is sunken down at the cathode. Up, down. So again, if I'm looking at this on a continental scale, I would say anything that is in the ocean that is a depression would be what I would first assume as being a negative cathode point. And then anything that is risen up like this especially with these cracks and creases around the outside. Just visually, I would say, hey, that looks like an anode. Interesting. Well, I'm gonna let it keep going. All right, it's 7:30 p.m. on Tuesday, and wow, that water's gotten much darker. And it almost looks like there is I want it, like on the top right of the anode, looks like a canyon. Almost looks like a river system, just from it cracking around. I don't know, it's definitely looks different than I thought it would. Well, it looks like this process is going to take
Many days.
I wonder if I had more power, how fast would this process be? It is still just bubbling away.
All right.
I don't know how long this video is going to be, but this is going to be a lot of data to compile for sure. All right. Woo. Going back to time lapse. Well, hello. It is now 12:30 a.m. Wednesday morning. And it's come a long way. It's gotten really dark. It doesn't look like water to me quite like it should, but of course there's all kinds of things in here. I have this slight fishy smell too, so maybe it's the oils from the fish that have come to the top along with whatever else is in there. All right. Okay, well, I'm going to let this run overnight, and I will see you later today, or shall I say tomorrow. Good morning. It is 6:46 a.m. on Wednesday. I think it's Wednesday. even know what day it is anymore. But here we go. This is where we're at. What was that? Did you see that? It's weird. It's not a pleasant smell. All right, it's now 1:37 p.m. on Wednesday. Well, it's quite obvious to me that in this scenario, the anode pulls up material and the cathode essentially sinks the material. Well, it's 6 p.m. on Wednesday, and I don't think I hit record, so I may have missed a little bit, but here's where it is now. Kind of interesting. I see down below the submerged portion here on the left now has a bunch of cracks in it. Very interesting. Reminds me of potentially how septarian nodules might be formed. Not sure, but we're gonna see what happens. I'm gonna let this keep going. All right, it's 11:40 p.m. on Wednesday. I don't think I'm gonna retire, so see you again tomorrow. It's 1:05 p.m. on Thursday. Here's where we're at. All right, guys, it's 6:30 on Thursday, and I think what I'm gonna do from here, because this has taken a while, and I don't want to just pour out what's in there already. I want it to just naturally do what it does until it's completely dried, which I have a feeling this might go on for another week. So what I'm gonna do is maybe check back in every once in a while, but I'm gonna stop time-lapse recording. And I'm gonna come back at a later time and show you where it's at when I come back next. All right, here you go. Well, it is 9:35 on Friday morning, and this is where it's at so far. Check this out. Look at that little fly right there. He's still alive. So I wonder if I could stick my finger in there and not get electrocuted. But I'm not gonna try that. All right, be back later. Okay, it is Friday evening at 8:30 p.m. and this is what we have so far. Looks like a lot of that water has dried out or evaporated, split, like these bubbles over here. So I think what I'll do
Is time lapse again?
It is 1:10 a.m. No, excuse me. It's 1:11 a.m. on Saturday, September 19th, also known as Saturn's Day. Saturnidis. Pretty cool. Look at this. Wow. So, finally starting to dry up. Okay, it is 5 a.m. on Saturday, and I was live streaming my fish, my live fish, so I ignored this for a while. So here's where we're at, and I think I'm going to leave this time lapse now because it looks like most of the water is now evaporated from the surface, and I think it'll start doing some more interesting things here soon. So I'm gonna leave, I don't know which is better. I'm gonna leave the light off. All right, and we'll time lapse now and see what happens. It's 2:24 a.m. on Sunday. It is now 9:30 p.m. on Sunday, September 20th. And this is what it looks like. There's still a charge difference going on between this 10,000 volts DC, with the cathode on the left, which is the negative, and the anode on the right, which is the positive. So as you can see, this is the result of the water splitting with hydrogen at the cathode on the left and oxygen at the anode on the right. I can see right now the moisture layer is really focused right there in the middle section where it's splitting and cracking. It's quite interesting patterns that it's making. So I am going to leave this overnight and see if I capture any major difference. Hopefully this will be getting to a point to where it will be more dry than wet. And I think that's where the magic's going to happen as far as crystallization process, turning this mud into a rock or stone and potentially fossilizing these two fishy. You can see right there is my algae eater, kind of has risen back up to the top since the beginning. I can see its scales kind of showing there, so it'll be interesting to see how that turns out, as well as the trout, and the tail is just right about on this side with the head down over here. All right, we're gonna go back to time-lapse mode. It's 3:16 a.m. on Monday morning. Well, it is 2:47 p.m. on Monday. It's been almost a week now, and I can't tell that it's done anything in the past day. I'm gonna try to move this electrode and see if I get an arc, which I do. So it's still trying to dry. It's still wet. Well, I guess the plan is to just let this keep going. It is September 21st at 10:18 p.m. It has officially been over 1 week since I started this experiment, and this is how far we've come. It's essentially mostly dried. The clay is still moist, and at this point, I am wanting to change it up a little bit. My impatience has gotten the best of me. What I set out to do was to have electrolysis exchange the liquid until the liquid disappeared. So, in my opinion, it has. I could let it sit here for a longer period, but I'm bored. So what I want to do is take this, and I'm going to just have the anode arc to the clay to speed up the process and perhaps draw some of those minerals faster. I don't know if that would or not, but either way, we're gonna make it more exciting with some arcs. Oh, I killed it. It's not what I wanted to do quite. I wanted it to just kind of be balanced. Come on, man. All right, let's position it now that I can. I want it to just kind of be roughly over this area to arc to it. That's what it is right there, I think. But I don't want it on the glass. Not quite. All right, how about right there? That is not a pleasant smell.
Serpent, plasma snake. Oh, that's cool. It's extracting some moisture there. There you go.
So it's jumping. Stuff's starting to look vitrified. Spirals. Just likes that one spot. Wow. That's the dragon. Sorry, guys.
Oh snap, there's my little fishy. Wow, you see this? You can see the moisture wicking away and then sucking it, just evaporating and coming back. Weird. Look at that. Is that electroplating this? Just building this up? All right, it's 11:55 p.m. on Monday.
Okay, so it's 3:34 a.m. on Tuesday morning. It has been 1 week and 1 day since I started this experiment, and apparently the arc has stopped, meaning enough water was dissolved out of this to end any kind of conductive current or circuit. So it's broken now and ended. That's great. That means my experiment is over.
It's over. It's over.
I see that my fishy is gone. I do see his spine. Interesting. Well, let's turn off the variac and interesting. I'm gonna come back to this later, but that's a wrap. Good evening. It is Thursday. It's been a couple of days since this experiment ended, and wanted to come over and just check to see, is it truly out of moisture or will it arc again? It looks like it's still arcing. So, see it doing its work on the side. It's pretty cool. There's that all familiar hexagon. That's bright. Arcing across the gap and burrowing through the mud. It's awesome.
dragon wants to go that way now. Wow. Okay, I'm curious. I'm going to stop this and let everything cool down and come back and see, does it follow the exact same line? Because it's obviously burrowed down in there. So here's where we're at so far right here too. Alright, we'll come back. Alright, let's give this another round. So seems like it is now gone. All right. So it's official. Make sure I got all that off, because I do not want to die. All right. So I noticed the cabling inside of here has actually absorbed a lot of that iron oxide. That black iron oxide has gone into this cable. And you can see it goes all the way up here. So it got sucked inside that jacket. It would be moving that direction. That's interesting. And this cable still looks inside shiny, and it is definitely in there. Not ready to destroy this thing yet, but I'm just gonna get a close up here. Let's see if I can. Oh, that's definitely odd down in there. Lines and lines of these crystal filaments. Look at how that little cavern system formed in there. It looks like caves. And of course you got the little valley floor that water would drip down through, and people would think that water initially carved it, but while it was water, it was a lot different form. Wow, I have a lot to look at here. I think I should get the microscope out. Look at that. What are those? What in the world? That's
Strange.
oh, there's my fishy. That was my algae eater. Oh yeah, and it was just etching all that stuff away. It's crazy.